Welcome to Part 4 of the MC2105 Restoration Series. In Part 1, we learned about the history of McIntosh and some details about the MC2105 amplifier we're restoring. In Part 2, we recap the power supply, and in Part 3, we recap the input board. If you missed those episodes, you may want to go back and check them out. In this video, we'll replace the thermistors, the input capacitors, and recap the driver and meter boards. Let's begin. So here's a closer view of the thermistors. The thermistors are used in the circuit as a slow start. The way a thermistor works is that when it's cool, the resistance is very high. As the current flows through it, it actually heats up, and when it does that, the resistance decreases and allows more current to flow. I'm not sure if these are bad, but they look a little they look a little kind of ground. So again, we're just going to replace them because the kit included 2 new thermistors. And at the end of all this, we'll test some of these parts and see. Thermistors are a little difficult to test, though. I mean, we can test the resistance when cold, but to really see if it's working well, you actually kind of need to not only test the resistance when it's cold, but also when it's hot. Okay, our desoldering iron should be all warmed up, so why don't we go ahead and remove these thermistors. I'm going to turn on the fume extractor now. Okay, and there we have our 2 thermistors removed. Let's take a look at these compared to the new ones. So just like with any resistor, thermistors don't have a polarity, so they can really be installed any way. However, we're going to orient these so that we can see the writing on the thermistors themselves, just so we can confirm what type of thermistors were used. Okay, and if I consult my diagram that I drew, we can see that there's 1, 2, 3, 4, 5 terminals. 1, 2, 3, 4, 5. Terminal 1, 2, 3, 4, and 5. We had a thermistor connected between terminals 4 and 5, and another between terminals 4 and 2. So let's install our new ones the same way. Let's start with terminals 4 and 5. You can see that the leads on the new thermistors are significantly larger gauge than on the old ones, so having a little bit of difficult time getting it through this first terminal. Let me keep trying. Okay, there we go. Okay, one thermistor now connected between terminals 4 and 5. Let's connect the next one between terminals 4 and 2. Let's go ahead and just remove these excess leads here. Going to use a little flux remover now to clean these up a little bit. And just in case we have any solder blobs in here, let me get out the blower and blow this out a little bit. Okay, looks good. Let's move on now to replacing those 2 Mylar capacitors on the input jacks. Here are the 2 Mylar caps that I want to replace. They're 0.22 microfarads, and they're right on the input jacks going into the amplifier. The style of capacitor I've actually encountered before with components from the 60s and 70s, and I've had trouble with them, so I definitely want to replace these, even though, as you can see, it's a difficult place to access. So let me get a socket wrench and remove this bolt and see if we can't get that shield out of the way. Okay, here's the bolt that I removed. Put that aside for a sec. Let's see. Okay, there we go. Okay, now with that shield out of the way, hopefully you can see this a little bit better. This first capacitor here is connected to this lug on the switch, and the other side of this capacitor is connected to the positive terminal of the left RCA jack. These are the back of the jacks here. This capacitor here is connected to the positive terminal of the right input jack, and the other lead connects here to this lug on the switch. Note that on the left-hand side of these capacitors, they've put some insulation on there, so they're to prevent shorts, because it's a little crowded in there with a lot of different wires and terminals. So we'll do the same when we replace ours. So in addition to the video I'm taking now, I've also taken photos of this area so it could help us put this back together again. These are non-polarized capacitors. They're Mylar, so we don't have to worry about orientation, but just so we can recall where everything is hooked up. And I've also done this quick drawing too, which you can see here. Got the desoldering iron all warmed up. Let's go ahead and start removing these. Okay, it was tricky, but there's our first capacitor removed. Let's now work at putting the new ones in. Okay, and here are our 2.22 microfarad replacements. Again, let's compare those to the originals. These guys always look like candies to me. The way these leads come in, I notice that they'll break off right here. And that's the problem that I've noticed. The leads will separate from the capacitor body itself, causing intermittent problems. So yeah, whenever I see these, I just yank them out. Okay, now this first one I'm going to install is going to go from this terminal on the switch. One end of the capacitor will go there, and the other end will go here. And again, remember on the left-hand side of this, we're going to add some insulation to this side, just so there's no short circuits. But let's roughly measure it out first to see what we're looking at. Between the new ones and the old ones, you can see how much wider apart the leads are on the older style, which really suits this scenario much better because the connection points are pretty far apart. Here with the newest style, it's going to be tough to make that span between here and there. Let's see if we can do this though. Yeah, not great. I'm sure these capacitors that they provided in the kit are good, but you know what? I'm going to see if I have something a little bit different style capacitor, a 0.22 that is going to be better suited for this, because these are there's just not enough lead here to work with. Let me see what I've got. Okay, looking through my stock, I found these two Mylar capacitors, which are rated for 0.22 microfarad, and they're really just, they should be ideally the right physical size to fit in here. Now note that these are only rated for 100 volts, whereas the originals here and the ones provided in the kit are rated for 250 volts. 100 volts though is going to be absolutely fine here because this is the input portion of the circuit, so the 100 volts is going to be just fine, and they should fit in there just right. Okay, looks like we'll be looking at something along these lines. Now you can see here, two leads here are a bit vulnerable to touching, and this one as well. All right, let's cut some heat shrink to size. Right about there for that one. So I'm going to use my heat gun here. I'm going to push that into position and give it a squeeze. Okay, a little more. Okay, that one fits in there well. Let's take a look at the second one. And let's cut some heat shrink to size. Okay, and on this one I'm going to put heat shrink on both leads. Alright, let's see how this works out. Come on, you can do it. Get in there. Okay, there's our first lead. Alright, I know, it looks ugly. Let's see if we can fix this up a little bit. Okay, that looks pretty good. Let me get in there with my magnifier and make sure that we don't have any leads touching. I'm going to solder this one in first, and then I may elect to remove this one and put a little more insulation. I didn't put insulation on this lead, and I may do so. Let's get this one soldered in first. Let's pull this other one out though, and put a little heat shrink on both sides of this capacitor. Okay, let's get that reinstalled. Very, very difficult to work in here. And I knew it was going to be, but it was worth it again because I just don't like those other capacitors. I don't find them to be reliable. So yeah, it looks good. We have our new capacitors installed, and that should do the trick. Okay, I've got the amplifier flipped right side up now, and we're going to begin work on the two output boards. This board here for the left channel, and this one for the right channel. We're going to need to remove the two boards to recap them, and also to remove these jacks. This amp was used with LWE speakers, which use negative feedback to help improve the bass response of the speakers. They were a very unique design, sold in very limited quantities back in the late 60s and 70s. To use the speakers, the amplifiers needed to be modified so that you could tap into the input portion of the output board. These are the output boards, but these actually connect to the input portion of the board, again to introduce the negative feedback signal coming from the speaker control unit. We're not going to be using those types of speakers, obviously, so I want to get these out of here and get the circuit back to original. Now, these two boards appear to just plug in, but I can't just pull them out just yet because they are attached to the standoffs here. There's a standoff here connected to this big heatsink, and another one here from there to there connecting to this heatsink. So let's remove that, and then hopefully we can just pull these boards out so we can work on them. Let's start by removing the screw that holds this standoff in position. You can see that's loosening up already. Okay, and there's our screw for that. Note here this white board I have. This is just to protect the rating on the transformer, so as when I flip the amplifier around it doesn't get damaged. So I tried to protect things as much as possible. I showed you earlier how I protected the meters and also delicate text and things like that. You can scratch very, very easily. Before you know it, you've got a scratch on your hand, so it's better to just protect everything from the beginning. Let's see if we can't lift this board out now. Okay, I've got it out of its socket. I just need to be careful here because that standoff so it doesn't grab on anything. Okay, there we go. You see what a nice design that is. How great it's going to be to work on this now. Okay, let's go to our right channel. Okay, and put the other screw here. Where did it go? Let me put this one in there for safekeeping, and let's see if I can't find. Must have rolled off. Okay, I see the screw right there. Let's put that somewhere safe before I lose it again. As a matter of fact, I think I'll screw it right into that standoff so we know where it goes. Okay, now let's try to remove the right-hand board. Just rocking that back and forth gently. Almost there. And just being careful not to break anything on the way up with that standoff sticking out. And there we go, the right channel. Just want to compare. Okay, they chose slightly different points to solder it. This one used the point here and here, and this one, instead of going here, this one was mounted there. What's going on here? This looks a little, I guess that's okay. All right, but we've got a broken foil here. You can see, looks like the foil was intentionally split right here. Okay, we have to confirm that, and on this one as well. The foil has been removed, so I want to make sure that wasn't part of the modification, if that trace is supposed to be connected or not. So going to have to check the schematics on this because I really want to get this back to original and get rid of all these mods. Here I have one of the output boards on my PC board holder ready to be worked on. You'll note that in the previous section I had noticed that the foil had been cut here, and I had wondered if this was part of the modification made to the amplifier to add this jack for the feedback circuit for the speakers. I also noticed that on this board there were quite a few differences in the component layout compared to the drawings and schematics that I had for the service manuals. That includes the actual service manual that was included with this unit at the time of purchase, and with various service manuals I found online. And I started to get worried, thinking that this board had been heavily modified. But in fact, doing more research and digging up the actual schematic for this particular serial number of amplifier that we have, this board is actually correct for the time that it was built. McIntosh themselves apparently had many versions of this board, and they were constantly, it seems, updating it and making changes and adjustments. So I encourage you to really do your homework before assuming that something's wrong with one of these boards or anything in these amplifiers until you make sure that you find the correct service manual for your particular serial number. And in fact, with the restoration kit that I purchased, apparently the capacitors supplied were for a different version of serial number of the amplifier. These are the two electrolytics that we're going to replace, and they did not provide the correct value for this electrolytic, so I'm going to use one of my own that I have on supply. In addition to replacing these two electrolytics, we're going to remove this jack, which is soldered on here at these 2 points. When I first saw this capacitor piggybacked over this resistor, I assumed that that was also a modification made for the feedback circuit. However, I've confirmed that this was actually done at the factory by McIntosh, so that will stay. I also noticed that looking at the schematic for this board, that McIntosh indicates that this resistor and this resistor here are both factory selected for the value. These both provide bias to these transistors. So these are critical, and you can't go by the schematic for the value. Based on the color codes, this one is measuring fine at about 120 ohms. This particular resistor on both boards in this position are measuring a bit high. According to the color code, they're supposed to be about 160 ohms, and they're quite a bit higher than that at about 180 or so. Doesn't sound like much, but these are gold band resistors, so they really should be much closer. And these are, again, providing the bias for these transistors, so they're very critical to getting this to operate correctly. Now, when we have this all plugged in, we can confirm the voltages on these transistors to make certain that this is providing the correct amount of resistance. But before we get there, I just want to make sure that we're starting as close to possible. So what we'll do is we will actually remove this resistor and test it to see if it being in circuit is affecting it. So we're going to just remove the resistor on both of these boards in this position to double check and confirm their value. Let's start by removing the jack from the circuit. So we're just going to need to desolder these 2 points here. One here and one there. Okay, there we go. And I'll say this, of course, in case somebody were to ever want to use that particular brand of speakers again. Definitely won't be throwing this out. Everything that I take out of my restorations I keep, so this will be saved. So I'm just cleaning up the solder a little bit, removing the old solder, and clean up the trace. Let's put some fresh solder on there. Okay, now before we do the replacement of the 2 electrolytics, I'm curious about this resistor. Let's pop that out and confirm its value. Now that we have it out of circuit, let's check it for resistance, see what we get. These resistors are supposed to measure 160 ohms. Let's see what we actually have. Yeah, a bit high at 185, 186 ohms. That's not good. We're going to replace this resistor. And interestingly, I checked all the other resistors on both boards, and every other one checks out. For some reason, this resistor here in both positions is running a bit high. Could have something to do with the demand placed on it over the years, helping to regulate the voltage for that transistor. Okay, so I didn't have a 160 ohm resistor, so what I've done is I've put two 320s in series, and you can see here that those are measuring at about 163, can you see that? About 163 ohms, so that's well within our 5% tolerance. Let's go ahead and get these two installed. Now to do this, I'm going to take advantage of these extra holes in the board. On some variations of this board, there are actually capacitors that go here, and they connect to the same points. And there's just a solder bead covering them up. I'm going to desolder these, and being able to have that extra horizontal space is actually going to help us to mount this. So first thing I'm going to do is, let's flip this over and remove those two solder beads. This lead will go into this first hole. This longer lead will go up here. That's going to go right about there. I'm just going to mark that. Our bend will go right about there. Okay, I'm just going to, where's that mark? Right there. Okay, and that puts a 160 ohm resistance into the circuit now to replace our 160 ohm resistor, which is measuring a bit high. Flip this over now and solder that onto the board. Trim this lead. Let's go ahead now and replace these electrolytics. Let's start with this one here. And I'm going to, let's see, mark those, the positive and negative. I have a, a little bit of a confused marker situation here. I have a black marker with a red cap. And that means I must have a black marker with a red cap around here somewhere. No, that's all red. That's all black. Don't actually know where this one came from. Let me put this one aside. And let's use our red. Oh no, here it is. No, that's red. That's red. Okay. All right, very confusing. Red and red. That's our positive. Oh, I want to show you something. On the schematic, this capacitor is listed incorrectly as having the negative here and the positive there. So this is actually incorrect. And this is true of every schematic I've seen. And that's confirmed not only by the way that the electrolytics are actually mounted, but also by these drawings. Every version of this drawing I found for this amplifier has the positive oriented there. Okay, so that's the correct way. Let's start though by removing this one. The PC boards used in this amplifier of very good quality. This is about the era where I think they started refining the technique for getting these boards to really work well. The foils are not delicate. Sometimes you have to be careful with some lesser brands or some earlier boards where this foil can be very, very difficult to work with, because just the slightest amount of heat on it lifts it right up. And you find yourself having to repair the actual foil, but not so with this McIntosh. Very good quality boards here. Here's our 10 microfarad 50 volt capacitor. And again, with this one, they did not provide the correct value that I need, so I dug through my collection, and I'm going to use these Nishikon fine golds, which are rated for 10 microfarads at 50 volts. However, these are radial style, not the axial, so we're going to have to spread these leads apart to get it to fit correctly. Not a problem though, because there's plenty of room on this board. Okay, this is our negative side and our positive. Find the center point. We're going to have a bend right about there and a bend right about there. Drop that in place. And that'll fit just like that. Okay, let's solder that one in position. Trim those leads a little bit. Just double check our work. Negative and positive. Okay, let's move on now to this one. So now if you see me working with the cutters, what I'm doing is, if there's any little solder left on there, trying to cut the connection between the lead and the board. Again, these are high quality boards, but I'm very mindful that nonetheless this foil can be broken. So I'm just trying to gently separate that. If I try to just lift that up, the foil may come with it. So if I cut it first and then I attempt to separate it, you can have better luck. Again, not as critical on a well-made board like this, but it's something I've gotten in the habit of doing. I'm going to get the soldering iron. I'm going to use it to push the leads through. Heats it up a little bit, breaks up any bond there might be remaining with the solder. That one's through. And now I'm just going to reach from the other side and try to pull on the capacitor. There we go. Almost there. Okay. And you can see that the board and the foil are still in perfect condition. Let's take a look at this electrolytic, a 330 microfarad at just 3 volts. Okay, and our replacement, we're going to use the capacitors that were provided in our kit, 330 microfarad, but at 16 volts. And again, we can see our dot here oriented with positive to my right. And if we orient it this way, we can see not only that the negative is pointing the right direction, and we can also read that this is a 16 volt, 330 microfarad electrolytic. Let's solder that in place. Okay, it looks good. I'm going to now clean up this board a little bit, remove the flux, get rid of some of this dust on here. I won't show you the other board because it'll be exactly the same as this, so it'll just be a repeat. Okay, moving along, we have the recapped output boards here and here reinstalled. I've also taken this time, I've gone through and I've cleaned this area up a little bit, sprayed down the heatsink and all of these boards with a little bit of the safety wash, electronics cleaner, blasted out all these areas, swabbed them up just to get rid of any the dust and just to clean up the look a little bit. I don't know if you can see it in the camera, but there is a spot of rust here. And let's see where else. That's probably the worst spot. There were a couple of other areas that had little tiny bits of rust, and I attempted as best I could without removing all of these heat sinks because the corrosion was really not that bad, and I just kind of got in there and I used a little bit of chrome cleaner to clean that out. It's not going to get any better, that's for sure, but I don't think it's going to get any worse either, so I'm just going to leave it as is and I'll keep an eye on it. This amp should be treasured from this point on, so I don't expect it to be in any poor conditions, and I would hope somebody would have the sense not to leave it in the garage or something like that. I don't expect the corrosion to get any worse. If it does at some point, then yes, these will all need to be lifted out and the chassis will need to be addressed. Okay, now on the 2 boards that we recapped, I did go through and check the resistors. These other heatsink areas would have the larger transistors and a lot of the very high wattage resistors. I did not check, again, because I would need to disconnect each of these from the bottom and pull these out to really be able to get in there and test things. This amp was working well, so I don't have a lot of suspicions that we have any faulty resistors in here. We did have the ones on the bias that needed to be adjusted a little bit, but certainly nothing that's causing the amplifier not to work. So after we test everything, if everything checks out fine, then I'm going to assume that these resistors are good. We'll check our voltages, etc. Our next step is going to be to recap this board here, which is used to control the meters. We have a couple of electrolytics here and a couple of these Mylar rainbow looking capacitors, which I want to get rid of. So what I'm going to do now is attempt to remove this board. We have a screw here and a screw here, and hopefully we can keep this in place and be able to work on it without removing all these wires. Okay, so let's move on to that. Okay, so I've zoomed up a little bit on the board to give you a better view. Let's start by removing these screws. And you can see this board has the variable resistors. These are used to help calibrate the meters. We'll get to that later. Okay, let's remove this Mylar. So I've just gone ahead and removed most of the solder from the other components as well, but let's start with this Mylar first. Also note on the electrolytics, I have marked these with a red dot here for positive, red dot for positive, black and black dots for the negative of the 2 electrolytics. These leads again have all been bent, so we need to straighten those out before we can remove the capacitors. Okay, there's our 0.47. These are the replacement 0.47s. These were both provided with the kit. I'm not going to bother with trying to figure out the foil side on these. This is a circuit that's not on the audio signal, so we will not bother with that. All right, now let's remove this electrolytic. Now you may be wondering why I don't just simply cut these leads off. I just like to keep as much of the original as possible, just in case you never know you want to reuse the part, or make sure you have enough so that you can test this, because I am planning on testing these capacitors at the end. This one I certainly could just clip that lead off though. Okay, there's our electrolytic, and these are 100 microfarad at 3 volts DC, and our replacement is, these are 50 volts, I believe. That's correct. 100 microfarad at 50, okay? Let's move on to this electrolytic here. So for these, I'll show you. I'm just going to simply cut the leads off, try a different technique here. And we'll just snip. Because one thing that you have to be careful of is when you do snip, these little pieces of lead can go flying, and could end up in your component stuck somewhere where it may cause troubles later. So that's always something to be on the lookout for. Hold my hand in place to block it from flying. Oh, that one flew right at me. And you can see that way the component was much easier to remove. Got our new capacitor ready. One thing I noticed with the newer components compared to the older ones, even for the same values, for example, this actually is rated for a higher voltage, but the leads are much thinner on the newer components, and I found that consistently. So here's the original, which is only rated for 3 volts, and this is the new one, which is rated for 50 volts. And look at the difference in the size of the leads. Very interesting. I've noticed that consistently with modern versus older components. Okay, let's install the second electrolytic. Just confirm our work. You can't double check this enough, folks. Positive, positive red, negative black, negative black. And looking at the arrows again, and looking at the indentation. Let's move on now to removing this Mylar 0.47. Just straighten those leads a bit. And again, I prefer this technique as far as just cutting off these leads, because again, they go flying and you just don't know where they're going to go, and they could cause troubles later. Our 0.47, our new 0.47. I'll just orient this one the same way the other one is, with the writing facing this way. Double check our work before we solder. Did we? I don't think so. I was just noticed this post here. Did we lose a lead here? Did something fall off again? No, I don't see anything, so I don't think this post is used, but I will, I'll double check just to make sure. Okay, looks good. Let's flip this over and solder those components in place. Seems pretty good. Let's remove our excess leads. Now, once this is soldered, leave the wires alone. If you lift on this, okay, you're going to put stress on your solder, okay? Leave it where it is and cut it in place. And don't worry about leaving a little bit of extra lead on there, okay? As long as it's not creating a potential for short, okay? A little bit of extra lead is not a bad idea in case you need to remove the component and reinstall it. And you can see the long leads that McIntosh left on these posts and on some of these other components too. It's okay to leave a little bit of lead, okay? You don't have to get it completely flush. Looks good. I'm just going to clean up now the little bit of flux from this board and put things back in place. And I'll do that off camera. You've seen enough of me cleaning flux from boards, I think. That wraps up Part 4 of the MC2105 Restoration Series. Stay tuned for Part 5, where we'll test the old capacitors we removed and start the amp up for the first time since we made the restorations. To stay updated, subscribe and click the bell. And if you like this video, please give it a thumbs up. I'll see you soon.